In this video, we're going to introduce statistics as a concept. So statistics is a science. It deals with collection, analysis, interpretation, and presentation of data. And what makes statistics very relevant for students is that it's something you are going to see actively in your lives as you go outside of the classroom. So we're going to do this by example. Suppose this question is posed to three different stats classes. What is the average time in hours to the nearest half hour you sleep per night? And we're going to create a dot plot, which is literally we're going to put dots of the data above a number line. So suppose this is the data that was collected in the three classes. Let's go ahead and do a dot plot for the first class. So I'm going to go ahead and graph this. I'm going to put a dot above the 5. And then I'm going to go ahead and put a dot above 5.5, so in the middle there. And then I have 3 dots at 6, so I'm just going to stack them on top of each other. 4 dots at 6.5, 2 dots at 7, 2 at 8, and 1 at 9. Now I went ahead and already did dot plots for the next 2 classes, if you want to go ahead and pause the video and put those down. But I want to now analyze this now. I want to kind of ask myself some questions. So I'm kind of looking at this information and I'm noticing that in the first class, the data is very spread out. We have somebody who has 5 hours, somebody who has 9 hours, and none of the other classes have that big of a spread of data. I noticed though that the majority of the data in the first class is kind of um, centered here between 6 and 7. That seems to be kind of where it is. And same with the second class. The data is kind of between the 6 and the 7. That's where it's heaviest. But in the third class, it's a little bit on the lower end. 6 is still very popular, but there's a little bit over there. It's kind of clustering around the 5.5 and the 6. So the first question we're kind of asked is, if we saw this or asked this question in an English class, do we think we'd see the same results? Why or why not? So here would be my answer, my interpretation of this. And of course, you might have some thoughts, and I'd love to hear it. But the idea is at a community college level, since most students have to take both math and English, I would think the data is probably going to look pretty similar in those classes. Now, even just in these 3 classes, we have some differences in the data, how spread out it is, and where it kind of ends up being in terms of the biggest amount of data. But we'll probably still see most students sleeping this amount of time because their work hours at the community college level tends to be pretty consistent throughout. Now, maybe if this question was being posed at a four-year university, we might see that differently. Because at a four-year university, some students may not have to work. They might be able to go to school full-time, and therefore they're able to get better sleep throughout the night. Whereas at a community college, we see a lot of people who are coming back to school. Therefore, they work, they have families. Maybe sleep is just not, unfortunately, the big priority they'd like it to be. So I would answer this question. I do think the results would be the same. Or similar, at least. There might be some variation between the classes, um, especially if we're asking at the community college level. So at the community college level. Might be different, though, if we're looking at a different school. That's a V. Okay. Where do your data appear to cluster, and how might you interpret that? So as we just kind of talked about before, it looks like in the first class, it's primarily between 6 and 7 here. Same with the second class. Third class, it's very heavy at 6, but there are a couple at 7, a couple at 5.5. So it seems to be that 6, maybe 6.5 is probably pretty safe for most of the classes. So at least in the first 2 classes, it's clustered around 6 and 7. 6 to 7 hours. And then the third class, it's heavy around 6 hours. So the interpretation of that is that, yeah, as I just kind of mentioned, at a 2-year college, we have a lot of people who are working while going to school, and that's just kind of how they have to do it. So they may not be able to get as much sleep as somebody who is going to a 4-year school and maybe not needing to work. Plus, like I said, we see a lot of older students coming back and they have a lot of responsibilities with families and whatnot. So they may not be able to have as much time for sleep. So that's kind of how we interpret the clustering. It makes sense that it's kind of on the lower end, just because we're looking at a lot of working adults at the community college level. So this is how statistics works. We look at these three classes, and I'm talking about statistics, but notice I immediately jumped to talking about community college in general and how I felt like it would be similar to what I'd see in an English class and why. That is statistics. So, statistics, by definition, is the science, and I want to make note, I said it earlier, science, that is an important distinction, of collecting. Wow, I'm going to try to make that a little clearer. Collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. Now, the implication of it being science is that we're talking about data, because science deals with data. We're collecting data, we're analyzing the data, we're testing the data, we're doing experiments on the data, and then making conclusions based on what we're seeing. That is very similar to what we're doing in statistics. Now, we use a lot of mathematical methods, and the biggest one that we'll be using is probability. Probability is a mathematical tool used to study randomness. It deals with likelihood or chance of an event occurring. So, for example, I have done this in pretty much every statistics class I've ever lectured in. I have my students flip a coin, in particular, flip a quarter 10 times. Oops. And then record the number of heads you see. And I've been doing this for a long time. And I've seen most times, I've seen anywhere from 1 to 2 heads at the lowest. And I think the highest I've ever seen is 9 heads. What I have never seen is 0 heads or 10 heads. And the reason is we expect, on average, to see about 5 heads. And the reason is the likelihood that we'll get heads is 50% or half of the time. So we expect about half of the time to see heads and the other half to see tails. And it always freaks students out the minute they start getting several heads or several tails, the other side. So I've had students like keep flipping heads and they start worrying, what am I doing wrong? Am I like somehow manipulating the quarter? I've actually had their neighbors call them witches and wizards because they're like, how are you doing that? I'm just a mere muggle. So the idea is because we have this expectation that we see it 50% of the time, we expect to see about half of them be heads and tails. And if we see 6 or 4, not too bad. 7 or 3, again, not too bad. But imagine you flip the coin 10 times in a row and get heads every single time. You might start to worry that maybe you've done something wrong. In fact, the authors of the book actually took a moment to talk about this, who they actually tossed the coin 2,000 times. 2,000 times. They referenced a statistician who did it 24,000 times, got about 12,000 heads. And when they did it 2,000 times, they got 996, which is very close to half. So it's exactly what is expected. If you keep going, if you keep flipping the coin, even if you happen to get the first one 10 heads in a row, you really know that if you kept going, you'd start to see more and more tails sprinkled in, and it'd probably even out the more and more you repeat this game.